Hi dear students, let's see this question that came in JEE Advanced Paper 1 Physics in the year 2019. The question was from Doppler's effect and this was a numeric type question. This question was fairly simple and most of the students would have done this question. But yes, there was one particular assumption which if IIT would have written, then it would have been better. So let's see what I'm talking about. In this video, I will be talking about the solution of this question and the assumption that in my opinion IT should have mentioned and what we would have done if if we ignore that assumption. Okay, so let's see what's happening over here. There's an observer who's moving at 36 km per hour, and these are two trains. S2 is at rest and S1 is moving in the direction of S2. So basically these two tracks are basically perpendicular, and at the shown instant this is 800 meters and this is 600 meters. Velocity of the sound in air is 330 meter per second. So basically we have to find the beats observed by the observer, right? So if you convert this speed in 108 kilometers per hour, this speed which is in kilometers per hour, if you convert this into meter per second, this will be 30 meter per second. Similarly, this will be 10 meter per second. ठीक है, ऐसे बचपन में मैंने याद कर लिया था कि 36 किलोमीटर पर आवर मीन्स 10 मीटर पर सेकेंड. ऐसे मेरे को समहाउ ये याद हो गया. तो फिर 36 मीटर पर सेकेंड से जो 30 तो मैं ऐसे ही कर लेता हूँ, मतलब 36 इंटू 3 108 होता है. तो फिर 10 इंटू 3 जो है 30 हो जाएगा. मतलब 36 किलोमीटर पर आवर को मैंने 10 मीटर पर सेकंड ये याद कर लिया है, तो उससे ईजी हो जाता है. मतलब वैसे तो 5/18 से मल्टीप्लाई करके ऑल्सो यू कैन डू इट, बट एनीवे. So let's move ahead. So at this instant, we can say one wave will be moving, which comes from S2, will be moving in this direction. Okay, the frequency is 120 hertz. So we can say that this, let's say this is F2, which is observed by observer. तो F2 की वैल्यू क्या आएगी? तो velocity of sound is 330. ठीक है, velocity of sound plus velocity of observer, because sound is moving towards observer, so which is 10, divided by velocity of sound with respect to source, and source is at rest. Okay, so this multiplied by 120, this is the apparent frequency observed by observer of the wave S2. Okay, now if you talk about this S1, so this wave would have traveled in this direction. Now remember, we are assuming that the assumption that I was talking about, we are assuming that sound actually will take almost no time to move towards observer. Okay, but in reality sound is going to take around 3 seconds, because if this is approximately 1000, this is actually 1000, but sound has a speed of 330 meter per second. So you can say that like approximately it is going to take 3 seconds. So by that time observer would have moved slightly upwards. So that will change the answers by a very small amount. I will do that calculation as well. But first, let's assume that this wave itself is what observer is catching over here. So in this case, this angle will be how much? 6/8. That means this will be 37 degrees, and this will be 53 degrees, right? So in this case, F1 is the apparent frequency which is observed by the observer. So we can say that this value will be approximately equal to 330 plus velocity of sound with respect to observer. So basically observer is moving in this direction at 10. So we can say that this will be 10 cos 53. 10 cos 53 is 6. Divide by 330 minus velocity of source. Source is 30 cos 37. Right? This is to be multiplied by 120. So if you take the difference of this, if you take the difference of these two frequencies, so you can do the calculations and you're going to get around 8.12 approximately. So 8.12 hertz you're going to get, and this was the answer that IT had given. Now let us see what is the calculation that I'm talking about, or what would have been the exact way of doing this. Okay, and let us see why it is also reasonable to take this as the correct answer, because the exact answer will not differ from this answer by a huge amount. Okay, so now if you think carefully, then this wave which is released now, like if you think carefully, wave is being released in every possible direction, in this direction, in this direction, every possible direction. Acha, before that, this value is not going to change. F2 will remain same, because if observer moves, it doesn't matter what amount of time the sound takes to reach to the observer. Relative velocity of the observer is not changing with respect to the sound, and hence we can say F2 is going to remain the same. So F2 is going to be again 330 plus 10 divided by 330 multiplied by 120. You can see over here, right? Because observer is going to move in the same direction. So whatever is the after, no matter after how much time the sound reaches, you are going to write the same expression, right? Even if the observer is here or here or here, anywhere. But in this case, if let us see, so here the sound is released in every possible direction, this way, that way, that way, this way, every possible direction. Okay. So let's say this wave, one particular wave which reaches over here, this is caught by the observer. That means observer had reached here, and this wave at the same time reaches over here. So observer is going to catch this wave, which source has released at this instant, at time 0, right? So this angle will not be exactly 37, will be slightly less than 37. Okay. So how to calculate this angle? First, we'll find time. Let us say some observer catches this wave after time t. So this distance will be 10t, because the speed of the observer is 10 meter per second. So this distance will be 10t. Okay. And this distance will be 330t, because sound has taken time t to travel this much. So we can apply Pythagorean theorem in this triangle, right angle triangle. This distance will be 600 minus 10t, right? Whole square, plus this is 800, is equals to this distance 330t whole square, right? Now you might be feeling that source will also move ahead after releasing the sound. That's correct, source will also move ahead, but we don't have to be bothered by that. We have to be bothered by this much, this distance, that at what distance observer has caught the sound. This actually is this wave which will be caught by the observer. So we are concerned with the position of the source at the moment of releasing, and we are concerned with the position of the observer at the moment of receiving. Okay. So source definitely would have moved ahead, but we are not bothered by that. So if you solve this quadratic equation, you are going to get one negative value and one positive value. The positive value will be approximately 3.09 seconds approximately. And it is of course reasonable, because you can think that this distance will be approximately 1000, slightly less than 1000. So is the speed of sound is around 330. So definitely sound will take around 3 seconds to move this much, right? So you can see this now, if we know the value of time, so we can definitely calculate like this distance, right? This will be 30.9. So now this distance will be 569.1, right? 569.1, correct? So this distance, once this distance becomes known, again we will apply the same formula that we have done over here. Instead of taking theta as 53 and 37, like this 37, we now know the value of new theta in terms of cos theta sin theta, because this distance is known, hence we can calculate this theta, and we will apply the same formula and we'll get the different answer. But as you can see that this theta has not changed much in the, like this cos theta, if you see, or tan theta, any theta, if you will calculate, so it will be very like slightly less than 37, and hence it was a reasonable thing to do the question in this manner itself. But I thought that it will be a nice thing to discuss the correct approach, because in some of the situations it might happen that theta changes by a huge amount. In that case, you will have to do by this method itself. So I am hoping you will be able to do that beyond this. Cos theta or tan theta, we will be able to find out. Tan theta will be equals to this distance, which is 600 minus 30.9 divided by 800. So this will be 569.1. Okay, divide by 800. So you now from here you can do, like you can find the value of cos theta and sin theta and everything, and you can apply the same thing. So f1 I'm writing in terms of theta itself. So this will be again 330 plus velocity of sound with respect to observer. So that will be equals to 10 sine theta, because this will be 90 minus, so 10 sine theta divided by 330 minus velocity of source at this moment, which is 30 cos theta. Okay, into 120, of course. So this will give you the exact answer, which will not be much different from or given like the IIT answer. It will be a nice practice for all of you to see what do you get, and you will see that it will not be different from much different from 8.12. That's all. Thank you.